Section 3.6 Derivatives of logarithmics or log functions. What we need to do here in this section, first thing I want to recall the properties of logs or natural log. So the natural log of the product is the natural log of x plus natural log of y. Natural log of the quotient is natural log of x minus natural log of y. Natural log of x to the m is m natural log of x. And also another thing to know is the change of base formula, natural log of a, natural log of b. Those are important to know for calculus. So if one thing here in logarithmic functions, we're going to look at the natural log first. If y is natural log of any function, then what is y prime? Y prime is f prime of x over itself. F prime of x over itself. To apply this formula, let's try to find the derivative of natural log of cosine of 5x. And we're going to try x cubed times natural log of x. So what's the derivative of this? Applying the formula, it says take that function here, find the derivative of that function over itself with no natural log anymore. And what is this? The derivative of cosine u, if you forgot that, cosine u, it's negative u prime sine u. So it's negative 5 sine 5x, and keep the denominator the same. That would be okay for an answer, but it would be really nice if we can rewrite this as negative 5 tangent of 5x, because sine over cosine is tangent. That would be the best answer. For the next one, we can move on with this. Y prime is product rule. Derivative of the first one times the second plus the first one times the derivative of the second. Derivative of x cubed is 3x squared. Keep this the same. Keep this the same. And derivative of natural log of x is the derivative of x over itself. That would give us this one plus x squared. We can make the function more complicated and ask you to find the derivative for it. Say something like this. Of course, everyone took a minute to think about this. And based on the formula, this is like our f of x. You're going to need to do f prime of x over itself. That will be a lot of work to do, because you need to do quotient rule and you will have like complex fractions involved and radicals. But guess what? We can try to make this much easier than how it looks like by using algebra. And what I mean by algebra, using the properties of natural log. Because I have x squared plus 8 divided by, the division becomes subtraction, like so. Nothing can actually be done for this one. But the other one, you can write this as 1/2. So you can write as x plus 3 to the 1/2. And bring the 1/2 down, natural log of x plus 3. Then, what is y prime? y prime is the derivative of this, which is 2x, over itself, minus 1/2 the derivative of this over itself. That's all we need to see. No product rule, no quotient rule, nothing. So the first two steps were algebra, and then we used the calculus in the last step. How about, as a question to ask, if y equals log of f of x base b, what would be y prime? The one we have been finding was natural log. Natural log means it's the log base e. Well, let's do this. Let's use change of base formula to convert this into natural log of f of x over natural log of b. This can be rewritten as 1 over natural log of b, that's a constant, times natural log of f of x. So I just rewrote it. Then what is y prime? Well, this is a constant. It doesn't affect anything. Derivative of natural log of a function, it's the derivative of that function over itself. Or you can simply say the derivative of the function over natural log of the base times the function itself. That would be the formula for the derivative for log any base. It doesn't have to be base e, any base. We may look at an example. Find y prime if y equals log base 7 of x squared plus 5. So to find the derivative for this one, we say y prime is the derivative of this 2x natural log of 7 times the function itself, which is the x squared plus 5. How about if we would like to find y prime if y equals x squared square root of x plus 2 divided by x plus 1 to the third power. The first thing you might note here, there's no logs, there's no natural log, there's nothing to do with logs. Since there's nothing to do with logs, the first thing comes to mind is like, why do we have to go over this in this section? What does this have to do with this lesson? Well, I tell you what this has to do with this lesson. We can use logarithmic functions to make this easy to find the derivative for. Because if you want to go straight forward, find the derivative of this, you're going to be using quotient rule, product rule, and the chain rule all at the same time with radicals involved. It'll take a lot of time. So to make it easier, what we do, we take natural log both sides. For the left-hand side, nothing can be done, so we just bring it down. For the right-hand side, we do natural log of the top minus natural log of the bottom. Keep the left-hand side the same. Here, we do natural log of the first one plus natural log of the second one. minus, bring the 3 down. I'm doing all algebraic work, simplifying all these terms. The left stays the same. You bring the 2 down. The radical, you bring it outside as 1/2. I cannot expand anymore or bring anything down. So now we can differentiate. The goal is to find y prime. Now differentiate both sides. Differentiate both sides. What do we get? Y prime over y equals 2 times derivative of natural log of x is 1 over x plus 1/2. Derivative of this is 1 over x plus 2 minus 3 times derivative of this is 1 over x plus 1. Then what is y prime? You multiply both sides by y. You get 2 over x, 1 over 2 times x plus 2, and 3 over x plus 1. Is it done? No, it's not done yet because we need to get the answer in terms of x only. So I'm gonna rewrite this as x squared, square root of x plus 2 over x plus 1 cubed. This would be the final answer. This is called, in calculus, is called logarithmic differentiation. Let's look at another example. Find y prime if y equals x to the x squared. What we learned in the past, if we have a function, y equals a function to a constant, say a, you can find y prime using the chain rule. If it's a to f of x, we can also find y prime. But if you have an f of x to g of x, there's no formula for that. There's no formula. And that looks like the example you see here. So then what do? We say we can't find the derivative for this? No, we don't have to say this. What we do is we need to check out one more thing. We need to check out one more thing. Is how do we go back? How do we go back and try to find this using derivatives? So how do you find the derivative of something we learned today? This can be done by bringing that thing down, and the only way to bring it down is to do natural log of both sides, like so. Okay, so we're gonna move on. By the properties of logs, it allows us to bring this down on the right side, the x squared. Then we can differentiate both sides. Derivative of natural log of y is y prime over y. Here we use product rule, 2x times the second one, plus the first one times the derivative of the second one. Multiply both sides by y, 2x natural log of x, and this can be simplified just an x. The last step is replace y with x to the x squared. That gives 2x natural log of x plus x. As a final note that you may be able to use in the homework, the e that we know, like the pi, e is 2.7, is defined as the limit as n goes to infinity of 1 plus 1 over n to the nth power. Keep that in mind.